Hello, my name is not Matthew, and in this video, I want to talk about the math of DnD 5th edition. There's this notion going around that having advantage is statistically the equivalent of having a +5 bonus. As far as I can tell, this notion comes from a video by Matthew Colville.
Advantage, as you probably know, means you're going to roll two 20-sided dice and you're going to take the highest one and use that as your attack roll. But what does that mean mathematically? Well, you may be surprised to learn that mathematically, rolling two 20-sided dice and taking the highest instead of one means, on average, you're +5 more to hit.
Colville's math probably looks a little bit like this. The expected value of a d20 roll is 10.5. Statistically, that's the value of my first roll. The relevant possible values of my second roll are between 11 and 20, the average of which is 15.5. 15.5 minus 10.5 equals 5. Therefore, advantage is statistically equivalent to a +5 bonus. The problem is that the value of each die is independent from one another. So the expected value of both die is actually 10.5. And since you don't know which die is the higher one, you can't ignore half the result on either one of these dice. As a result, if you rely on the expected value of a single die to determine the value of having advantage, you should in fact conclude that advantage is worth nothing. And that conclusion would also be wrong because the approach is wrong. If you want to know the value of having advantage, you need to know the distribution of the result of an advantage roll. When you make an advantage roll, there are 400 possible results, all of which fall somewhere between 1 and 20, but you don't have the same amount of each count, unlike on a regular roll. Once you know how many of which roll you have, you can calculate the arithmetic mean, which will be the expected value of an advantage roll. Here is the distribution of an advantage roll. The expected value of an advantage roll is therefore 13.825. So, an advantage roll is statistically equivalent to a bonus of 3.325. These advantage rolls have the inverse distribution. So the expected value of a disadvantage roll is 7.175, and therefore a disadvantage is statistically equivalent to a penalty of minus 3.325. While it's true that for most D20 systems you can think in terms of 5% increment, that does not apply to the advantage mechanic. Since I have you here, here's a distribution of a super advantage roll. The expected value of a super advantage roll is 15.4875, which is statistically equivalent to a bonus of 4.9875. Matthew Colville claimed that having advantage is statistically equivalent to having a +5 bonus, and yet, even a super advantage isn't exactly quite that good. Matthew Colville is a great pillar of the tabletop community. I respect his skills as a game designer, writer, literary analyst, and a DM, just to name a few. This was not meant to be an attack on him, but this +5 myth has spread far and wide in the community. It's damaging to our theory crafting, impairs the min-maxers among us, muddies the effectiveness of strategical decision, and come on, we are a horde of nerds and geek. We should be able to do math correctly.